Sasikal students, so we started understanding the concept of derivative, concept of limits uh, in our class 11th by taking a beautiful example NCRT has taken. Let me just quickly repeat it. That it took this example that let's imagine there's a ball and this ball is dropping down. Its initial velocity was 0 meter per second. Under the effect of gravity, it fell down. So obviously, ball must have come here. After 1 second, the ball must have come here at some distance after 1.5 second, and the ball must have come here after 2 seconds. And at the instance when the time was 2 seconds from the fall, the time was 0. Let's say we had a stopwatch, the time was 0, and when the time was 2 seconds, gradually the velocity of the ball is increasing, and the distance traveled, till 1 second, till 1.5 second, till 2 second distance traveled was given by the function s is equal to 4.9 t square. A beautiful example they have taken. So now the pertinent question was, which helps us to understand the birth of calculus, or you can say why we have the existence of limits, and hence the concept of derivatives of the functions, and hence the understanding of rate of change. This is not if, this is of, I'm sorry, rate of change of a function with respect to some variable. In this time it was, in this case it was time. It can be rate of change of some function with respect to any other variable, time, maybe pressure, maybe anything, with the height, with the force, or with anything, like with respect to anything. Okay. How the function is changing with respect to something. So that rate of change of function with respect to something, right? Okay. So our question was that when the time passed after the ball has fallen was 2 seconds, what was the velocity of the ball is at this instance when the ball has fallen, when the ball has fallen, and from t is equal to 0, the stopwatch shows t is equal to 2 seconds. The ball passed here. Ball passed this point. So at this point, exactly what was the velocity? Now, we have this, understanding of velocity is equal to distance by time. A very simple, very naive notion. All right. And then, people understood this little better that, this v is what? This v is actually the average velocity, and that can be given as delta s by delta t. So when we said that from this equation, I can calculate s at 2 second, s at 0 second, distance traveled at 0 second was 0, and distance traveled at 2 second was, I could calculate from here, putting the value for t is equal to 2, I can calculate distance traveled in this time interval of 2 seconds, 0 to 2. Then this was actually the average velocity during this time interval 0 to 2 seconds. But my question was different. My question was, what is the velocity at 2 seconds? Now it's not possible to answer this question. First, we need to understand why it's not possible, because this formula needs time interval. In this case, let's say when I find V average taking t is equal to 2 second, Now first I will find delta S, 4.9 into 2 square divided by time interval was 2 seconds. So I was getting 19.6 if I'm right. 2 to the 4. Correct. No, education 10. Correct. Divided by 2. I was getting Northern Tara, 9.8 meter per second. This 9.8 meter per second, what I got was not the instantaneous velocity at 2 seconds, rather, it was the average velocity. A very vague figure, a very misleading figure of what actually would have been the velocity at 2 seconds. So, in other words, I can say I was basically asking what is the instantaneous velocity at 2 seconds. It wasn't possible. This 9.8 figure was misleading because I intuitively I thought a researcher, uh, concept oriented student thought that no, intuitively this might not have been correct value because velocity is changing, as the time is increasing, the velocity is changing under the effect of gravity. So what the student did and what the NCRT has beautifully done, they have taken another time interval. So initial time interval was 0 to 2 seconds, and again they took 1 to 2 seconds, they decrease the interval, and then they find the average velocity, because this is the only formula for the velocity we had before the birth of calculus, delta s by delta t. And in this is average velocity in this time interval delta t. By finding delta s, what was s2 minus s1, s t can be written as t2 minus t1, means final time minus initial time, distance traveled in that time, delta s. Okay, so finally, I'm not going to repeat what they say. When they decrease the interval, the velocity was different. Interestingly, the velocity increased from 9.8 to some value I'm not remembering now. And finally, what they did, which I have after discussion with the students, when they decrease the time interval, they kept on decreasing rate of change of something. This is exactly we have wanted to find out. Rate of change. We are changing. We are seeing how this V average is changing, and at what rate V average is changing. You know, when I say rate means I'm dividing something by time or time interval. So here the velocity was different, and when I took a very small time interval, that was in the book, it is 1.99 second to 2 seconds. The time interval is very small. It's yeah, just subtract to 1.99 from 2. I make mistakes sometimes. I'm not doing it. So I think it is fraction of a second. Okay. So in this time interval, the velocity, average velocity came was, according to 1.99 second, it was 19.551 meter per second. So the doubt which came from the conscious or subconscious mind of a student that this velocity is not correct proved to be right. That when the interval was small, the average velocity increased. So if the instantaneous velocity had been this, it would have been same. Well, it wouldn't have got affected by changing the intervals, but it's the average velocity is getting affected when I'm changing the interval. So that means there's something more in the picture which I'm not able to read. That how I can find time velocity at 2 seconds. So I ended here, but I went one step further with my students. We did 1.999 seconds to 2 seconds. We further decrease the interval because I know in the limit actually I want delta t to approach to 0. With delta t cannot be 0. Some students always ask me, sir, why this delta t cannot be 0? Simply because if delta t is 0, I will get V average as it at infinity. If I directly want to answer this question, what is the instantaneous velocity at 2 seconds? At 2 seconds, I'm not giving time interval. So what is delta t? Yes, any student? If I'm straight away asking, what is the velocity at 2 seconds? So indirectly, what is the delta t? Anyone can answer?
0.
0. And when I divide delta s, I'm not able to find delta s also. That's another issue because I am able to find delta s only in terms of s2 minus s1. So I don't have this, I don't have this. So I get this answer actually as, 0 by 0. So I assume that at 2 seconds the body has not traveled anything, and that is true. Exactly at 2 seconds, when there's no interval before 2 or after 2, this is right. Velocity, the body has not traveled any distance at 2 seconds. This is correct. So this is of the form of 0 by 0. But then, like when I studied limits and derivatives, I got students got some idea that whenever a limit is of the form of 0 by 0, there is a answer. There is a hidden answer. So by this NCRT, I would appeal through this video, students, don't leave NCRT if you want to crack some competition, and please don't get bogged down by these competitions. That's not your life. If a person doesn't get selected in IIT, so he still can have greater life than a graduate from IIT if he is concept oriented. There are lots of platforms in the world Almighty can give you. Just go after the concepts. Don't be bogged down. But yes, no harm in trying. You should try. There are good people, good professors there, good environment. You might enjoy. You might not also. Okay. So now students know that 0 by 0 is possible. The limit, whenever the function comes in this way, 0 by 0 is possible. Students know it. Okay, but in the starting, student doesn't know about all this. But now students know because we have gone a little further. We know limits, left hand limit, right hand limit, all these things. So students know. Okay, so guys, see when the time when the interval was further decreased. So I think this interval is maybe 0.001 second. Ishma, is it right? This is the interval, 0.0.9992 second. No, 0.001 second, very small interval. The book, I think, ended at 0.01 second of interval delta t. So we went little one step further, and then we got more refined value of average velocity, and that was 19.5951 meter per second. See, students, this thing shows that the velocity is is trying to come to some value. You know, it's like uh, maybe you know a person cannot speak. You know, person is not able to speak. He's having pain in the leg, so he's pointing out to his friends. He's pointing towards his leg to his friends that, oh, there's a pain in my leg. He's not able to say. Let's say a person is gunga. He's not able to say. I don't know what is gunga in English. So he cannot say. He cannot speak. Anna. So he's pointing to the leg. So his friends will understand. Oh, there's some problem with the leg, and they'll concentrate on the leg, not on his stomach or his brain. Similarly, this function, these values are pointing to something, that what is the velocity at 2 seconds. You see, when I simply changed the interval from 0 to 2 second to 1 to 2 second, there was drastic change in the value of average velocity. It was like 9.8. Can any student tell me, fatafat, from 1 to 2, what was the velocity? Uh, from 0 to 2 seconds, it was 9.8 meter per second. From 1 to 2 second, what was the average velocity? Can any student tell me?
14.7 meter per
You see
second.
that? Wow, how the drastically velocity changed. And anyone, any human being who changes his character or his statements drastically, people don't believe him. So we didn't believe that this average velocity is the instantaneous velocity. But now I am compelled to believe that my velocity at 2 seconds would be something near to this only. And also my intuitive is telling that it will be slightly more than this, because if I make time interval more smaller, like 0.0001 second, so it's again pointing to some. See, it's not crossing 9.6 meter per second anyway. This calculation is full of ecstasy and enjoyment. You should do. Students who like research, like they should take intervals of 0.00001 second, then find average velocity, then 0.0000001 second, then find average velocity. They'll be surprised to see the velocity is not crossing this limit. Why? we'll have the answer in the same video. The same trend we are seeing from the right hand side. When the students try to find the velocity at 2 seconds from right hand side means they wanted to find the velocity at 2. They somehow, they they fall flat on the face because this formula doesn't help them. It says, no man, I cannot help you. So we need something else. And there was a birth of calculus. I don't know, people calculus, people sometimes relate Newton to the birth of calculus. I don't. I think there were some other mathematicians, who contributed equally, and this beautiful concept in mathematics came. It's like hitting exactly in the dark at your destination, at your target, hitting exactly at the dark. That is how I define calculus, and it really helps you. Putting the payload in the right place at right angle in the orbit, the result of calculus. you know all these space mission programs, they have some other relation with calculus. Without calculus, they cannot go. But yes, they get sense from physics, so physics and maths goes hand in hand. All right. So guys, now I'm trying to find the velocity from right hand side. Means first I took long interval, like I took 0 to 2 interval here. So I took the brother of this interval, that is 2 to, any student can tell what was the brother of this interval? 2 to 4 second. Any student can answer. What was the first interval? It was 2 to 4 seconds. Then I decreased it. The brother of this interval 1 to 2 second was 2 to 3 second. And then I decrease the interval. I saw something interesting coming when the interval is trying to approach 0. So I took 2 to, the book ended here. I think the book ended with 2 to, I'm going to go to next page. From the right hand side, the book ended at uh, 2 to, I think it's 2.01 second. So interval of point, point zero 0.01 second, delta t. So that gave the average velocity of 19.649. All right. From the left hand side, it's going towards 19.6. From the right hand side, also, you see, guys, 19.649. But I went further. I requested the students to find out at 2 to 2.001 second. And the answer was astonishing. The answer was 19.6 6.049. I can presumably think that it may be right, but you can check it, cross check it. But I think these digits tell me the validity of correctness of this calculation. Okay, so it was 19.6196. See, students, again, even how small interval you take delta t means 2 to, maybe you can take 2.00001 second, you'll find astonishing here the velocity is not going to again cross 19.6 meter per second. So I want Ishma to answer that what is all this calculation showing a researcher. Yes, I want your understanding and what you are able to say. See, actually, we wanted to find the velocity, instantaneous velocity at 2 seconds. Till now, after taking 5, 6, 10 lectures, we are not able to find on the velocity, which we are going to do now. Yes, Ishma, what do you understand from the left hand side? The limit was trying to be, you know, it was 19.5951. Last value we got 5951. And here we are getting this value 19 point this. Yes, Ishma, you want to say something?
I can conclude that the results are converging of left hand limit and right hand limit.
Right hand debit. Perfectly said. Amitabh Singh, you want to say something? That basically I want to come here. This is my actually target in the dark. So I want to hit this target. And you want to say something about this? Whatever operations I'm doing, left hand side calculations and right hand side calculation. You want to say something? You're afraid? Okay, fine. Your time is over. Okay, so we take Ishma's statement that the results are converging. So is it 19.6? Now we're going to see that. Okay, our brain says, our intuition says, yes, it must be 19.6, because left hand side, whatever small intervals we are taking, it's not increasing by 19.6. It's like a wall. All the values, finally coming to the this wall, from the left, right hand side, and from the left hand side, all. Okay. So guys, now having done all that, and having understood all the labor, and understood limits and everything, and also understood that when I say limit delta t approaches 0, delta s by delta t is equal to ds by dt. Yeah, there was a geometric side to this also. Very quickly I will explain. This was the function of s is equal to 4.9 t square, and I wanted to actually find velocity at t is equal to 2 seconds, instantaneous velocity, which was not possible to be found from the average velocity concept. So I took these two, then this was the average velocity, then I took less interval, so the slope of this curve changed as the delta t approached 0. I took a point very near to this, so I got this, that it is slope at this point. So this derivative is basically slope at this point. Slope at a point is possible to find of the curve. So this was another geometrical way understanding this problem. Okay, so that also you can see from NCRT book. So finally, I concluded this, 3-4 lectures before. Limit delta t approaches 0, delta s by delta t is ds by dt. That is derivative of the function s. What was the function s? S was 4.9 t square with respect to time. So a very, very important thing, the new thing in the mathematics, derivative of a function with respect to time. Okay, what is the meaning of this? It means what is the rate of change. See, whatever we have found was actually, you know, ds delta s corresponding to some delta t. Then I took less delta t, then I took less delta t, and I was finding this. And then I was finding rate. What was the rate of this function? It would be delta s by delta t. Rate of change. When I compare this and this and this, I will find rate of change. Rate of change. Okay, so this is rate of change of function. If the function was s, I can write it as f of s or fs, whatever you want to write down, with respect to time. With respect to time t. This is the meaning of ds by dt. This is what I did, all these calculations was rate of change of function with respect to time. Okay, and this is known as derivative of a function, students. This is derivative of function. So very, very important concept. Now there are things I want to explain, but me being a poor teacher, I don't have time, enough money to pay to Zoom, so that I can cross 40 minutes. So in 10 minutes, I have to complete my whatever is there in my mind. So let's hope we're able to complete. All right. So, so guys, now mm, I want to define what is derivative, and I want to apply this concept to find out that whether I'm able to find out the velocity at 2 seconds by this new concept. Let's see. And whether my limits approaching 19.6 from left and right was right calculation. Was that approach right? I'll just see now. They say derivative, how I'm defining derivative. So you just see, you have to listen very, very carefully to this. It says definition, derivative. If f is a real valued function and a is a point in its domain, means inputs of definition, right? derivative of a function, then derivative of function at a at a is defined as, see here, very very important thing, limit h approaches 0. What is h? Taking this, it's related to delta t approaches 0. Related to that, just see the analogy. Limit h approaches 0, limit of which function? F of, we wanted to find out the fa. In our problem, we wanted to find out the velocity at 2 seconds, or you can say if f of s in last case was 4.9 t square, I'm sorry, f of t, right? F of t, this is f of t is the output of this range of this is basically f of t was distance, f of t is distance and t is time. So f of t was 4.9 t square. Then derivative of function at a means we wanted to find out the derivative of this function represented by f dash t. Derivative is represented as f dash t, and definition I'm going to give just now. Just keep getting connected. I wanted to find out its derivative at, yes Ishma, t is equal to what? How much seconds?
2 seconds.
Correct. You are connected. I'm happy. Means in other way, I wanted to find out uh, the limit of the function at 2 seconds. That way also I can say, derivative of the function at 2 seconds. Okay. So it's defined as, I'm repeating again, I'm sorry. F is a real valued function and a is a point in its domain of definition. All right. Derivative of function at a means what I wanted to find out, the value of velocity at 2 seconds. Derivative of function at a is defined as limit h approaches 0. What is h? You'll understand. H, anything, h some number, h delta t approaches 0, f of a plus h. Students, what is this? This is what we were doing. We were trying to find out f of t. What was f of t? That was distance at little more than 2, little more than 2, little more than 2, then little less than 2, less than 2, less than 2. Am I right? Like it was 0 to 2, then 1 to 2, then 2 to 3, 2 to 4, then 2 to 2.01. So there's this additional thing. Our a value was 2 seconds. F a plus h minus f of a divided by h. Very very important, uh, very very important concept, very very important definition. But what is the use of understanding if it doesn't give my results? I'm asking this, hey come on, give my answer. Can you help me find out velocity at 2 seconds? I know I'm full of curiosity. It is approaching 9.6 meter per second. Is it true according to you? Let's see. So I said, what is derivative? Derivative, and my function was f of, f of t is equal to 4.9 t square. Am I right? And here I'm defining derivative as what? Limit, can you say, Ishma, h approaches 0, f of, I wanted to find the derivative of a function at a. So f of, instead of t, I write a plus h, marginally more. Value of function, you want to find the value of function at 2. So find the value of function little more than 2. And then subtract the value of the function at a, means at 2, divided by h, means h. In our case, it was delta t. Try to relate this with our initial limit delta t approaches 0, delta s by delta t. It is same, but stated in a general way. Now, whatever it is I want. Come on, give me the answer. So I'll rewrite the function in this way. How will I rewrite the function, students? Give me a second. I want to rewrite my function. Maybe I can write like this. Uh, yes, student. So I can write this function as f of x is equal to 4.9 x square, right? You can write f of t is equal to 4.9 t square also. Okay. So basically my intention was to find out f dash 2. See, I just now stated that f dash x, this is f dash x, this is all is equal to f dash uh, f dash, if the function is f of x, f dash x means derivative of the function. Okay, derivative of f of x, f dash x, right? So f dash 2 I want to find out at x is equal to 2. X is time, this is time. Okay, fine. So I'll apply this. So this will be equal to f dash 2 would be equal to limit h approaches 0. Students, my f of x is what, Ishma? 4.9 x square. Am I right? Can you tell what will be f of x plus h? And particularly x, what is the value of x I want to find out? Derivative at 2 seconds. I want to find out f at 2 plus h. Can anyone tell what will be this? Do it fast. F of x is 4.9 x square. Instead of x, you write 2 plus h. So here it will be what? It will be 4.9 x square. Instead of x, I will write what? 2 plus h whole square minus f of a. F of a is 4.9 2 square. I want to find the value at 2 divided by h. Students, this is equal to limit h approaches 0, 4.9. This will be 4.9 into 4 plus h square plus 4h minus 19.6, right, divided by h. And students, this is equal to limit h approaches 0. I can take h common. I will get 4.9h plus 19.6 divided by h. H cancels with h. I got 19.6 meter per second as the answer. And that is correct answer. My intuitions are proven right. I've successfully today